Amphibians. Amphibians are vertebrates that can live in two different environments, land and water. Amphibians are extremely sensitive to chemical runoffs, pollutants, and other toxic substances. The population of amphibians has severely fallen due to several factors, such as diseases caused by viruses or fungi, depletion of the ozone layer or climate change, pollution, drought, or other human activities. Exposure to pesticides can also interfere with development. Since the 1980s, the amount of amphibians has dropped.
I like turtles.
How pollutants climb the food chain. Human activities has disturbed nature and animal habitats, resulting in deaths and sometimes complete extinction. Examples of human natural disturbances are forest fires, insect infestation, pollution, etc. The biggest change is the introduction of synthetic or human-made chemicals that has affected animal habitats.
A few moments later.
Oh my god, it's a fire. This is how human activities disturb nature.
Breaking news! A forest fire has erupted in northern BC, as you can see behind me. The cause of the fire seems to be a lit joint left by rambunctious teens.
Bioaccumulation. Bioaccumulation is the buildup of synthetic and organic chemicals in living organisms. A chemical bioaccumulates when the chemical is taken up faster than it is broken down and excreted. Chemicals are temporarily stored in fat tissues. If these chemicals are not used, excreted, metabolized, or if the accumulation is too high, it can be harmful. Bioaccumulation of species can affect births of organisms and also the ecosystem. Keystone species are organisms that can greatly affect the population and health of ecosystems. An example is salmon. Biomagnification is the process of chemicals becoming more concentrated at each trophic level. Chemicals can be bioaccumulated and biomagnified when pollutants are stored in plant tissue or animal fat tissues. Small concentration of chemicals can cause problems at higher trophic levels. Examples are red tide.
PCBs are synthetic chemicals that were widely used in the 1930s to 70s in industrial products. They were banned in 1977 because concerns grew about their impact on the environment and human health. Synthetic chemicals such as PCB bioaccumulate and biomagnify. They also have a long half-life. They suppress immune systems and could possibly cause cancer in humans. Aquatic ecosystems and species that feed on aquatic organisms are especially sensitive to PCBs. Study found that PCBs will interfere with the reproductive system of orcas in BC until 2030. Even though the chemical is banned, orcas retain it in high levels, especially in the calves. Even if PCB enters ecosystems in low levels, by the time it gets to the orcas, it's highly concentrated in their blubber. PCBs are released into the orca's bloodstream where they interfere with the immune function, thus making the orca more susceptible to the disease. Persistent organic pollutants. PCBs belong to a class of compounds called persistent organic pollutants, or POPs. POPs enter the ecosystem in a form of insecticide spray. A well-known POP is an insecticide spray called DDT. DDT was introduced in 1941 to control disease-carrying mosquitoes. Although banned now, it has a long half-life and persists in oil for 15 years. It affects aquatic food chains by accumulating in plankton. Chemical accumulation is measured in parts per million, or ppm. 1 ppm means one particle of the given substance mixed with 999,999 other particles, which is equivalent to 1 drop of dye mixed with 150 liters of water. DDT is considered harmful or toxic at 5 ppm. It causes nervous system damage, immune system damage, and reproductive disorders in animals.
Heavy metals are metallic elements with high density that are toxic to organisms at low concentration. They can't be destroyed and can't degrade in the biosphere. Some metals such as zinc, copper, and selenium are essential to human health in small quantities. They can be found in water or in air. they are taken in through the food chain. Heavy metals can bioaccumulate with organisms and biomagnify, moving up the food chain. The three most common heavy metals are lead, cadmium, and mercury. Lead is naturally present in all soils. In the past, lead was used in insecticides, paints, and as an anti-lock ingredient in gasoline. Today, most products and manufacturing processes reduce the use of lead in their products to reduce the lead in the environment. Consumer electronic waste makes up 40% of lead in landfills. It is extremely toxic. It can be ingested, absorbed, or inhaled. Lead can cause anemia, nervous system damage, sterility in men, low fertility in women, impaired mental development, and kidney failure. Cadmium is found in Earth's crust. It is released to the environment through rock weathering, volcanoes, forest fires, electronic waste, batteries, the manufacture of plastics, zinc production, and phosphate ore mining. Cadmium is strongly attracted to organic soil and it is very dangerous. It goes into plants and animals eat the plants. It's very toxic to earthworms and other soil organisms at very low levels. It can cause death rates and lower reproduction and growth rates in fish. In humans, smoking tobacco is one serious source of cadmium poisoning. Tobacco plants can easily absorb cadmium. Cadmium accumulates in lung tissue. It can cause lung disease like lung cancer. Non-smokers can ingest cadmium through foods like mushrooms, shellfish, fish, and seaweed. Cadmium moves from the digestive system to the liver to the kidneys. It can lead to infertility and damage to the nervous and immune system and to your DNA. Every year, 6,000 tons of mercury is released through volcanoes, geothermal springs, rock weathering, fossil fuel burning, waste incineration, mining, and industrial uses like manufacturing batteries. Coal burning equals 40% of mercury in the atmosphere. It returns to Earth in rainfall and dust and binds to plants and soil particles to form compounds that are transported by air and water. In soil, it can change into methylmercury, which is highly toxic, and can bioaccumulate into the brain, heart, kidneys of vertebrates. In humans, methylmercury can be absorbed in digestion and enters the blood stored in the brain, affects nerve cells, heart, kidneys, lungs, and suppresses the immune system. In fish, methylmercury depends on their diet, their life dependency, and how high they are on the food chain. Reducing the effects of chemical pollution. The first method is to trap the contaminant in soil. Example, phosphate fertilizer is in lead, contaminated soil. This reaction equals lead pyromorphite, which is highly insoluble, which means it's not dissolvable, meaning it is less likely to spread in water and enter the food chain. The lead remains in the soil, but in a less harmful form. The second method is bioremediation. Bioremediation is the use of living organisms like plants and microorganisms to do the cleanup through biodegradation. Microorganisms that naturally eat chemicals and reduce them to non-toxic compounds can be added to contaminated soils. Plants can be used as stabilizers, reducing wind and water erosion spreading. Bioremediation can be used in industry, mining, forestry, energy production, oil spills, and leaks in oil industry.